This video contains a step-by-step guide on how to graph a rational function. A rational function looks like p of x divided by q of x, where p of x and q of x are polynomials. Here's the first step. You find any zeros. That's where p of x is equal to 0, the top function. The second step is you find any vertical asymptotes. That's where p of x is not 0, but the bottom function, q of x, is 0. Step 3 is you do long division to write your function as a of x plus b of x over q of x. This will tell you the behavior of the function for very big values of x and very small values of x. And the last step is plot points to use the guidelines that you find in step 1, 2, and 3 to sketch the overall function. So let's see this in action. How about this example? How about 2x plus 4 over x squared minus 1. Okay, so the first step is find any zeros where this top function is equal to 0. So I have 2x plus 4 is equal to 0. If you solve, you can subtract 4 on both sides, divide by 2. I think you'll find x equals negative 2 is the only place where this graph crosses the x-axis. Step 2. Let's find some vertical asymptotes. So some vertical asymptotes are where the denominator x squared minus 1 is equal to 0. Solving this gives x is either plus or minus 1. Step 3. It's already the correct form. Let me make that more clear by writing it as 0 plus 2x plus 4 over x squared minus 1. It's already of the correct form because the degree of the top polynomial is less than or equal to the degree of the bottom. And step 4 is, let's call this function f of x. So let's say this function is f of x. F of 0, that's a good point to plug in. If I plug in 0, I get 4 over negative 1, which is negative 4. If I plug in, negative 3, I get negative 1/4. And you can plug in more values if you need more points to determine what the overall shape looks like. So here is the graph. For large and small values of x, the function is close to 0. I have vertical asymptotes at plus 1 and minus 1. So here's plus 1, or minus 1, and here's plus 1. I have vertical asymptotes here and here. And I cross the x-axis at x equals negative 2. So over here at negative 2, I have a 0. I also know that if I plug in 0, I'm down here at negative 4. So let's say that's negative 4. If I plug in negative 3, I'm a little bit below this axis. So you can plot more points. You can see what's happening. You can plug in a number that's really close to negative 1 but still on the right. I think you'll find I get something that looks like this. So I cross the x-axis. Here I'm a little bit negative because if I plug in negative 3, I get a negative number. So I'm a little bit negative. I cross the x-axis. I go up towards this asymptote. Now I'm down here in the negative portion. I know I'll never have another 0. The only 0 was at negative 2. So I'm never going to cross the x-axis again. Since I'm down here, that means I must have a picture which comes up like this and then comes back down. And on this side of the picture, you could plot some points if you'd like and get a picture that looks like this. So there's the graph of this rational function. Let's try this again. How about if I have the graph of f of x, which let's say is x cubed plus x divided by x minus 1. Okay, the first step is find any zeros. That's where x cubed plus x is equal to 0. So x times x squared plus 1 is 0. That means x is equal to 0 is the only 0. Step 2, let's look at vertical asymptotes. Well, there's a vertical asymptote at x equals 1. Step 3, you need to do long division. So I'm not going to do it in this video, but when you do long division, you'll find that this becomes x squared plus x plus 2 minus 2 over 2 plus x minus 1. So I did long division before the video began, and I found this answer. That means the large and small values of x are close to this parabola. So this is the graph of a parabola. You can graph this parabola by finding its zeros. You could find its vertex. We did a whole video on how to graph parabolas earlier in the quarter. So you can graph that. Here, let me actually graph that over here. So I get a parabola. The parabola is going to go like this. I believe the parabola has no real zeros, so it never crosses the x-axis, but goes like that. That's my guide parabola. And I also have the vertical asymptote at x equals 1. So here at 1, I get this kind of vertical asymptote. I have a 0 at x equals 0, so the graph crosses here. That's the only place where the graph crosses the x-axis. And I could plot points. I could plot, let's say, if I plug in -1, I believe if you plug in -1, you get out 1. So here's, -1. I get a height of 1, which is here, let's say. Always plot more points if you're not comfortable about what the graph should look like, but here I think I'm ready to draw it. It hugs the graph of this parabola, it goes through these points, and then starts coming down this way. Now I know the graph can't start from the bottom and go up, because if I did that, then I'd have another 0, which I don't have. The only 0 is at 0. So that means I can't be coming up from the bottom like this. I must be coming down from the top and then approaching the graph of this parabola over here. Let's do one final example to finish this video. How about the function f of x is equal to x to the 4th over x to the 3rd plus 1. Okay, step 1. X to the 4th equals 0 means that x is equal to 0. That's my only 0. Notice, though, this is a degree. In the previous example, I had a degree 1, 0. This is a degree 4, 0, because I get x equals 0 works almost 4 times because I have a 4th power here. As we've seen earlier in the course, that means that when I cross the x-axis here, I'm not actually crossing the x-axis. I'm just going to kiss the axis and go back up to where I was before. We'll see in the graph. Step 2, vertical asymptotes. Well, I want x cubed plus 1 to equal 0. The only way that can happen for a real number x is when x is equal to -1. That's the only real root of this equation, but since we know the fundamental theorem of algebra, there are actually 3 roots. 2 of them just happen to be complex valued. Next, I'm going to do long division. I did it before the video, and I found x minus x over 1 plus x to the 3rd. That means the behavior for large and small values of x is given by the line y equals x. And then you can plug in some values just to get some more information about where things are. So if I plug in -2 for x, I believe you'll get, let's see here, -16/7. And if you plug in 2, I believe you get 16/9. This tells me I get a negative number over here and a positive number over here. All right, let's put it all together and get a picture of what's happening. So let's see here. I have the function crosses the x-axis at 0. So I got a value of the function here. I have a vertical asymptote at x equals -1. So here I am at -1. I'm going to draw a guideline here. That's a vertical asymptote. I have a slant asymptote, or the function approaches the line y equals x. So the line y equals x is a diagonal line that looks like this. I can plot more points if I'd like, but if I do, I will find the following picture. So it goes like this. By the way, I know it couldn't have gone up like my other alternative in this situation, because if it were to go up like that, I would have another 0, which I don't. Next, the graph comes down like this. It touches the origin here, and then since it's a 4th degree, it's never going to go negative. That means it's going to go up positive like this and approach the graph of this line. So there's a good graph of that function. Okay, wonderful.